All right, hey everybody. So let's just get started with the class today. So let's just talk about a couple of things first before we start doing some math. So for the most part, well, so I have that. So let's talk about like the syllabus first. So I have the syllabus on. You know what I can do? Let me. Sorry, 1 second. How would I do that on here? Okay, pretty sure I'm sharing. Let me check this. Yeah, so you know we have. So here's like the Canvas homepage. Where do we have it? I didn't put it on there. 24. So here's a couple of things that you'll need. So here's the syllabus. It kind of just talks about the I guess the main important thing here is, well, so here's my phone number. There's that or my email. Either is fine to reach out to me. You can text me if you want, or you can email me. Both of those are fine. And then for the people here, you saw this. Here's like the link for the Zoom room. And then here's the grading thing. So I guess maybe this is the only important thing on here that we can talk about. So there's two options. So there's a homework, which we'll talk about in a second, like where you can find those homework problems. Or there's an option where you don't do homework. But you don't necessarily need to choose which option. So you don't need to tell me I'm doing option 1 or I'm doing option 2. I'll just grade you for both of these options and I'll just choose the better grade. So if you don't want to do the homework, then you'll just be going towards this grade because this grade will be worse because there'll be 10% of your grade that's not going to be accounted for. But if you do the homework, then it's almost just kind of going to be like a free 10% of the grade. And then the test will be worth a little bit less, but the final has to be worth 30% for both options. That's like a department thing. That's kind of the only important thing from here. Oh, and I guess for the office hours. So if you, do I put that in there? So for the office hours, I'm basically free whenever. So just text me or email me and we could set up an appointment if you wanted to have help with the homework or help studying for a test beforehand. Yeah, but always feel, it's never like a bother if you text or email me to meet up to do this in office hours. So I can meet up pretty much whenever. Oh, what else is important on here? So on the homepage, so we have our Zoom room. Oh, this OneNote thing. So that's where I'll be taking, maybe you saw it for a second. I had that pulled up because I'm using my iPod or my iPad and also the computer. But anyway, so I'll do the notes on the iPad and then you'll see those notes I'm writing on the screen stuff. On that document I'm writing the notes on, that's like a OneNote document. And if you want to see what we did in class, you can just click on this OneNote link and that'll take you to the notes that we've done. And then the OneNote link, actually it updates as I'm writing. So I'm pretty sure you can just click on the OneNote link and as I'm writing, it also updates that OneNote link just as exactly as I'm doing it. The next thing, the schedule. So you can just look at this, this kind of has us an idea of what's going on here. It'll have the homework due dates and then also the days of the test and kind of, what sections that we're doing each day. And I should also actually post this on, I've sent out that email of the 4th edition of the book. I should post that on here too, just in case someone didn't see that email. But the homework will either come if you have the book from the bookstore or that edition I sent out. They're both, the questions are exactly the same. So it doesn't really matter which one you use. And then so when I have here, the homework, I just have it for chapter 1 and chapter 2 right now. If you just click on chapter 1 homework, this gives you the list of the problems. And it says up here too, to use either the 4th or the 5th edition. So these are the sections, 1.1 all the way to 1.6, and then you just do all these problems. I guess maybe on computer paper would be the easiest for me to look at. Oh, and also how you're going to submit it. So you'll do these problems just on like your own paper or whatever, and then you go to this tab over here that says assignments, and then you'd click on, I haven't made one for chapter 2 yet, but here's chapter 1 homework. You would just click on this chapter 1 homework thing, and it's going to look a little bit different for me. For you, there should be a submission link. So you would just submit it like a PDF file, and then I can grade it. And then how to do that to make it easier, if you have like an iPhone or an Android or whatever, there's an app. They're all pretty generic. There might be different on both if you have an Apple or like an Android phone. But the one I have is called Scanner app. If you just look on, if you have Android or an iPhone, if you just go to the App Store and type in the word Scanner app, it allows you to scan all of your all of the pages that you wrote on, and it turns it into one continuous scroll PDF. So that makes it a lot easier. So say if you're doing the homework and you have 25 pages, you're not posting 25 individual pages onto the submission link. You're just posting one big page and it's just a long PDF. And everyone's phone can do that. It's called Scanner app. If you don't have that, it'd be nice if you had like a scanner just to make that easier. So you're not like posting 25 different PDFs. Yeah, so that's for the homework and the submissions. I guess for the test, so we're not really quite there. I guess the first one, when is the first one? Going to the schedule. I think it has chapter 1 and chapter 2 stuff on it. Yeah, so the first test will be wait a minute, is this good? Yeah, so the first test, we don't have a first test for the first 2 weeks. So our first test will be on the Monday, I guess the third Monday of class. For that test, it'll just be on your own time. So I'll post like the test onto Canvas, kind of like over here, how I have homework or chapter 1, chapter 2, whatever. I'll just have like a test one, then you'll just download the test. And you'll probably have, yeah, I guess maybe just most like the whole day to do it. And then you would just submit it on here like you would submit a homework assignment. Yeah, I think that's the only things that are kind of important. Okay, so let's start doing the math things that we need to do today. Let's switch back to the iPad real quick. Oh, so for the videos, I'm pretty sure this is recording right now. So this will be like the first time I've recorded using Zoom. So hopefully this works just nicely and there's no problems. But so whatever this recording is, I think I'll just make a YouTube channel and I'll post all the videos on there. And then I'll post the link to the YouTube channel onto Canvas. So people who, aren't here, they want to rewatch the lecture, they'll do that. I'll figure that out after class, though, and then I'll send an email out to tell you guys what I did. Okay, looks good. All right. So let's just start with, let me, Let me print something off real quick. Not this one. Sorry, give me 1 minute. I want to print off that homework page. So I want to use that for just the problems that we're going to choose today. So to go over. Sometimes it does that. Okay. So for how I'm going to do these lectures, I'm just going to take like the homework sheet, and then all we're basically going to do is problems together. So there'll never be a time, like say when you're doing the homework or you're doing a test problem, and we haven't like done a problem similar to that. So yeah, so basically I'll just have the homework sheet here, and then we'll just go through and do a bunch of problems. I think that's how the best way to learn this class. Just gotta learn by doing it. So yeah, we'll just do a bunch of these together. And then you can, when you do the homework, if you choose to do that, just all the problems that we've done, there'll be similar ones that, we'll do here in class. So yeah, let's just do a bunch of stuff from 1.1. Okay. Where's the homework sheet? All right, so number 3, what's this? Okay, so so maybe some of this stuff too feels a lot like review, but maybe that's going to change quickly. So I wouldn't let these first couple of sections, like maybe I think that this class is going to be mega easy, because a lot of this stuff is pretty reviewish, and then it gets to be kind of things maybe like in chapter 2, chapter 3, and on, and it starts to become probably newer material. But anyway, so we'll start here at the beginning. And this first bit is just talking about given a point, how do we put it on a graph? So in general, we have like a graph like this. We have an x-axis, a y-axis, and then we have points on the graph. And the way we label it, let's say this is an A and this is a B. So just I need just a variable here. The way we label these points, this is going to be the point A comma B. So the first little bit in the parentheses, the x value, and the second bit is the y value, the B. So for example, say if we're doing problem number 5 in the book, it says we want to label, there's a bunch of points there and we just want to label them. So this is number 5. It gives us these points. We have the points -5. We'll just do a couple of them. So -5, 1. And how about 2, 3? And let's just choose the last one, 0, 1. So what we want to do is put these points on a graph. All right. So just to do that, we have these 3 points here. Let's draw a graph out. So here's our x-axis, here's our y-axis. And I'll start with the first one, the -5, 1. So like we said, the first bit in the parentheses, that's the x value, the second bit's the y value. So what this is telling us is we have to go to -5 on the x. So -5 on the x, and we're over here. And then 1 on the y. So just put 1 up there. And then we'll put a dot there. So here's -5, 1. The next point, 2, 3. So here's 2 on the x-axis. We put 3 up here on the y-axis. We put a dot over there. So here's 2, 3. And the last one, 0, 1. So 0 on the x-axis, but 1 on the y-axis. So right there, 0, 1. So yeah, I'll just basically just memorize that the first thing, the first number inside the parentheses, that's the x value, and the second number, that's the y value, and then you just put those onto the graph. Okay, so for the next bit of problems. So what does it mean for a point to be a solution of an equation? So let's say we have some equation. Let's just do it by examples. This first one, number 9. So the directions here are, so we're given a couple of points. 1 minus 9 and 0, 2. So remember, whenever we're given a thing like this, a parenthesis with 2 numbers, The first number is always an X number. The second number is always a Y number. It doesn't have to do with graphing. The problem doesn't need to say, here's a point, put it on a graph. It's just already known that if you're given a pair of numbers in this form, it's always, okay, here's your X value, here's your Y value. The instructions doesn't have to remind you that. So whenever you see something like this, that's what it always means. So here's an X value and here's a Y value. And so in this problem, it gives us 2 points. So another way of thinking that, it gives us 2 X values and 2 Y values. And what it wants us to know, is it going to be a solution to the equation? So the equation it gives us is Y is equal to 7X minus 2. So are the given points solutions? So what that means is, well, if I plug in the X value and the Y value of each point, do we get a true statement? A true statement meaning maybe something on the lines of like 2 equals 2 or 1 equals 1 or 0 equals 0. So if that happens, then we're okay. But maybe we'll get a situation where we plug in this X value, plug in this Y value, and we get something like 1 is equal to 5. And that's not true. So in that situation, it would not be a solution. So maybe just in general, if we get, actually, let's just do it by plugging these in. So let's start by testing the points. So let's start by plugging in 1 comma minus 9. So here, this tells us that X is equal to 1 and Y is equal to minus 9. All right, now let's plug those values into the equation and see if we get a true statement. So if Y is minus 9, that means we're going to get minus 9 is equal to 7, because here's the 7. Now we're going to plug the X in. The X is 1. And now we have minus 2. But notice this tells us that minus 9 is equal to 7 minus 2, which is 5. And that's not true. So, sorry, I copied the problem down wrong. This needs to be a minus 1. Actually, let's keep the problem like, no, let's make it same as the book. That was a minus 1. I copied the problem down from the book. Let's put this as a minus here. So the only thing changed is this needs to be a minus sign. So we're plugging in a minus 1. But notice here, so we have 7 times minus 1, which is minus 7. And then minus 2. So that equals minus 9. So you see we have a true statement. We have minus 9 is equal to minus 9. So that's good. This tells us that 1 comma minus 9 is a solution. All right. So now let's test the next point, 0, 2. All right. So here we have an X value of 0. And we have a Y value of 2. So let's see what happens when we plug those points in. So remember, the equation was Y equals 7X minus 2. So our Y is 2. So we're going to have 2 is equal to 7. X is 0. And now minus 2. But then what this actually just tells us is that 2 is equal. So 7 times 0 is 0. That means I have a minus 2. So 2 is equal to minus 2. That's not true. Let's not put an X. Is this right? So not true. So what this tells us is that 0, 2 is not a solution. Again, because when we plugged in that point, we got 2 is equal to minus 2. And then we know that 2 does not equal minus 2. 2 equal to 2. So because of that, we have 0, 2 is not going to be a solution of this equation. All right. We do one more. Let's do 13 together. So same problem. We have another set of points, minus 1/2, minus 4/5, and 0 and 3/5. Okay, so again, just 2 points. So we got 2 X values, 2 Y values, and then the equation that we have is going to be so this problem is actually, just from looking at this problem, this is I guess it's a little confusing because, so whenever you're doing these problems, if, like we said before, this is always an X value, this is always a Y value. Just assume that if you're given a problem, like in this right here, we don't have X's and Y's, we have A's and B's. Just assume that these pairs go in alphabetical order. So these pairs actually represent A comma B. That's sort of like bad notation from the book. I think it should just stick with X's and Y's unless it tells you otherwise. But anyway, so these pairs, they're not X's and Y's here. They're going to be A's and B's. Anyway, so, but still the same technique of the problem. So all right, now let's test both of these points. So we have the point, let's make sure we copied everything down right. So -1/2, -4/5, and 2a plus 5b is 3. All right, so let's test the first point. -1/2, -4/5. So here we're going to have a is equal to -1/2, and then we're going to have b is equal to -4/5. Okay, and so now let's plug those into the equation. So we're going to have 2a plus 5b is equal to 3. So let's plug in the a. We'll have 2a is -1/2 plus 5, b is -4/5 is equal to 3. So let's see if this is true. So you notice on the left-hand side, so we have 2 times -1/2. Really, we could think of 2, though, as 2 divided by 1. So notice how there's a 2 on the top and a 2 on the bottom. So those are going to cancel each other out. So all we're going to have right there is -1. And the same thing over here. There's a 5 on the top and a 5 on the bottom. So those are going to cancel each other out. So we're just going to have -4. So what we have here is -1 plus -4, which is equal to -5. But this needs to equal to 3, but that's not true. Because notice here we have this equals to 3 sign. This left-hand side is equal to 5, but we get 5 is equal to -3. That's not true. So this is going to tell us that's not a solution. So the point -1/2 -4/5 is not a solution. All right, now let's go to the next point and try it out. 0, 3/5. All right, so here we have an a value of 0. We have a b value of 3/5. All right, let's plug everything into the equation. So we have 2 times a, so 2 times 0, plus 5 times b, so b is 3/5. And see, what does this equal? We need this to equal 3, but we'll do that in a second. So 2 times 0, that's just going to be 0. Notice how the 5s cancel. So it's just going to be 3. And we want this to equal to 3. But notice we actually do get that. So this tells us that 3 is equal to 3. So that's good. So this tells us that 0, 3/5 is a solution. Let's put this in a box. And if there's any questions at any time, just feel free to interrupt me, and then we can talk about that. Okay, so let's move on to a different type of question. All right, so the next one, x and y intercepts. So this has to do with like the next 3 homework questions, 17, 19, and 21. So we'll talk about x and y intercepts several times throughout the semester. This is going to be a very more yeah, so it'll get maybe a tad bit more complicated as time goes on, but at the same time, not really. Anyway, so what is an x and a y intercept? Let's just first look at the definition just by looking at a graph. So say if we have a graph, we can draw something on here. It looks something like this. So the x-intercepts is where the graph touches the x-axis. So say like right here, actually let's do these in colors. So we have this green dot. So this is the x-axis. This is where the graph is touching it. So these green dots, these are going to be x-intercepts. It's where the graph intercepts the x-axis. There can be multiple of those, but there can only be one one y-intercept. So this red dot right here, this is where the graph touches the y-axis. This is the y-intercept. So basically, it's just, the x-intercept is where you touch the x-axis, and the y-intercept is where you touch the y-axis. But there's several ways we can represent that. So let's just talk about that for a second. So the x-intercept, just in words, it's where the graph touches the x-axis. So that's one way of saying it. And they're going to be a point. So if we touch the x-axis, that means the y value is 0. So it's just going to be a point x comma 0. So we'll have an x value. The x value may be 0, but the y value is always going to be 0. So if you look at this graph above at all these green points, at every one of those green points, the y value is 0. And we just have some x value. It doesn't really matter what it is. So the y-intercept, that's where the graph touches the y-axis. That's just in words, that's how we explain it. And then as a point, well, if we touch the y-axis, notice how the x value is going to be 0, and we're just going to have some y value. Again, the y value could be 0, but that doesn't, it's just the x value always has to be 0. So this is sort of the idea of an x and a y intercept. So now how can we find x and y intercepts? So if we have a graph, it's not too hard. We just look at the graph and just point, like here's the x-intercept, here's the y-intercept. But if you notice that all these problems, they don't give us the graph. All we have is the equation. So say if we look at, for example, let's do, we can do 18 and 20 together. So if we look at number 18, it's telling us to find the intercepts. Let's say find the x and y intercepts. For 2x minus 4y is equal to 8. So let's think about how we can do this without a graph. If we look above, what's really important is going to be these things in boxes I have right here. This is the best way to think about an x and a y intercept. It's a point. And it allows us to actually solve for the x and y intercept if we're just given an equation. So let's start with the x-intercepts. So look at the x-intercept up above. It says that y has to be 0, and then x is just that number that we get when y is 0. So another way to say that is all we have to do is set y equal to 0 and solve for x. And that x number we're going to get is going to be the x-intercept. So let's set y equal to 0. So we have our equation, 2x minus 4y is equal to 8. Let's just set y equal to 0. So if we do that, we're going to get 2x minus 4 times 0 is equal to 8. So that tells us that 2x, so we have 4 times 0, that just goes away, equals 8. Divide the 2 over, we're going to get x is equal to 4. So then we get that our x-intercept. In this problem, we're only going to have one x-intercept. We said above, like in this graph up here, how there's multiple x-intercepts. Sometimes we'll get several of them. Sometimes we'll only get one of them. In this situation, we only have x equals 4. And the way we write our answer is going to be the pair. So it's going to be the point 4, 0. The x-intercept and the y-intercept are points. So it tells us that the y value is 0 and that the x value is going to be 4. All right, so now let's do the y-intercept. So with the y-intercept, what we do is we are going to set, well, if we look above, see here's the y-intercept. The x value is 0, and then we're finding a y value. So here we're going to set our x value equal to 0. So we're going to set x equal to 0, and then solve for y. So it's just the opposite of the x-intercept. So we solve for y, set x equal to 0. So how do we do that? Well, our equation, like we have right here, the 2x minus 4y is equal to 8. Let's just set x equal to 0. So we're going to get 2 times 0. Then minus 4y is equal to 8. So the 2 times 0, that just goes away. So we just have minus 4y is equal to 8. We divide by the minus 4, and we're going to get y is equal to minus 2. So our point, remember the y-intercept, the x-intercept, those are points. So our x value is 2. Our x value is 0. And our y value, the one we came up with, is minus 2. So this is going to be our answer for the y-intercept. So we have our x-intercept is the point 4, 0, and then the y-intercept is the point 0, minus 2. Okay, let's do another one. How about, maybe we could do 22. So same problem, we want to find the intercepts. Find the intercepts of 3y plus 2x is equal to minus 6. Oh, that's not good. Oh, 1 second. You know, for the people here, chart this problem. Well, this only takes like 5 seconds to charge. Chart this problem. We'll go over the answer to this one like in a minute or two. So this is the same problem as the one we previously did. So just copy these steps up here and then see if you can come up with the right answer for problem number 22. Okay. Okay, let's go over this one together. Sorry, I might need to do that a couple. I thought I had this. This is like this pen for my iPad. I thought it was charged up, but it only takes like a second to like get several percent. So hopefully we'll be okay for the rest. Anyway, this problem. Find the intercept. So let's start with our x-intercept. Okay, so remember with x-intercepts, we have to set our x equal or set our y equal to 0, and then solve for x. All right, so let's set the y equal to 0. So 3y plus 2x equal to 6 or minus 6. Set the y equal to 0. We're going to get 3 times 0 plus 2 times x is equal to minus 6. So we're going to have 2x is equal to minus 6. And then x is going to be equal to minus 3 when we divide the 2 over. So then our x-intercept is going to be the point minus 3 comma 0. So our y-intercept, in this situation, just like before, we're going to set our x equal to 0 and then solve for y. So when we set our x equal to 0, so we'll have 3y plus 2. X is going to be 0, so 2 times 0 is equal to minus 6. So we have 3y is equal to minus 6. Divide by the 3, we're going to have y is equal to minus 2. So then our y-intercept is going to be the point 0, comma, minus 2. All right, so let's move on to the next problem. Let's see, what does this say? Oh, the distance formula. So this will be like for the homework 41, 43, yeah, those two problems. So first let's write down the distance formula and then say what that thing means. So, say if we have 2 points, something like this could be x1, y1. And then maybe a point over here, x2, y2. And we want to know what is the distance of this line. So to find the distance between these 2 points, we just have to use, there's an equation that you kind of have to have memorized, and we'll use that equation. So this is going to be the distance formula. So we have these 2 points, x1, y1, x2, y2. To find the distance between the two, so let's just use like this letter D. So the distance between the 2 points. So the distance between the points x1, y1, and x2, y2. So the distance between these 2 points is going to be equal to this equation. So it's going to be the square root. What you do is you subtract the x values, x1 minus x2, and square it. And then you subtract the y values, y1 minus y2, and square it. And it doesn't matter which order you subtract the x's and the y's in. Sometimes you can do x2 minus x1, y2 minus y1, and square it. In this particular formula, you could actually even do something like this. You could do x1 minus x2, and then y2 minus y1. You can even switch up the order and square it. It doesn't matter for this formula. But with that being said, it's just easier to memorize it like this. Like just memorize one way. So just do like, x1 minus x2 squared, and then y1 minus y2 squared. So anyway, this whole number right here, you can plug it in, simplify it. Maybe you have to use your calculator, or maybe you can do it by your head if it's an easier number. That's going to be the distance between those 2 points. So for example, say if we're going to be doing, do I have a calculator right there? Let's do 42 together. So what 42 says is we got to find, find the distance between minus 3, 7, and minus 3, 7, 2, 11. Okay, so let's find the distance between these 2 points. So the first thing we might want to do is label what is our x1, y1, and what is our x2, y2. Maybe we just call this first one right here x1, y1, and we'll call the second one x2, y2. Again, it doesn't matter which one we call what. We could have called this first point x1, or sorry, x2, y2, and we could have called the second one x1, y1. It doesn't matter. We just have to stay consistent. So we'll just call this first one x1, y1, and we'll call the second one x2, y2. So now let's plug everything into the formula. So the distance, so see how we have x1 minus x2 squared. So let's subtract the x values. So it's going to be minus 3 minus 2 squared. And now subtract the y values. So 7 minus 11 squared. Okay, so what's this equal to? Minus 3 minus 2, that's minus 5. So we have minus 5 squared. 7 minus 11, that's minus 4. So minus 4 squared. So remember that when here we're squaring a negative number. Whenever you square a negative number, the minus sign just goes away. So minus 5 squared, that's just 5 times 5, which is 25. And then same with here, minus 4 squared, that's just going to be 16. So we add these up, we get square root of 41. And the square root of 41 doesn't have a nice answer. So we can just leave our answer like this. We don't need to use a calculator. So this is as much as simplified as it goes. So what this is saying is the distance between these 2 points is the square root of 41. It's the distance between the points minus 3, 7, and then 2, 11. Okay, what's another problem we can do? Oh, so that was the distance. So the next thing we're going to do that has to kind of do with points and stuff is going to be the midpoint formula. So we just did up here, you see we found the distance between these 2 points. And this next bit right here, the midpoint, okay, midpoint we want to find, so let's just draw another graph. Let's say here we have a point x1, y1, Maybe down here we have a point x2, y2. Let's connect this with a line. Let's say we want to. So this is the point we're looking for, the point that's in between. So this is the midpoint. Did somebody have a question? Heard someone made a noise. Nope. Anyway, so right here, this is what we're looking for, the midpoint. So the midpoint is going to be a pair. It's going to be some number x comma y. Whereas the distance, just remember the distance for that's a number. That's the distance between x1, y1, x2, y2. The midpoint itself is actually going to be a point. It's not going to be a number. So it's the point that's exactly in between these two things. So the way we find it, the midpoint formula, so the midpoint is going to get given by this sort of like equation right here. So what we do is we add up our x values, x1 plus x2, and then we're going to divide that by 2. So that's going to be the x value of the point, comma. And now the y values, we add up the y values, so y1 plus y2, and then divide it by 2. So this is a point right here. So here's our x value, and then here's our y value. So like I said, the midpoint is a point. It's not just going to be a number. So let's use this formula to find the midpoint of, so if we look at, for example, 62. Let's do that one. That one seems fine. So we want to find the midpoint. Find the midpoint of 7 minus 2. And 7 minus 2, 9, 5. Okay, so first let's figure out which one is our x1, y1, and which one's our x2, y2. Let's just call this first one x1, y1, and we'll call the next one x2, y2. So notice that the midpoint is tells us add up the x values divided by 2, and then add up the y values and divide by 2. Okay, so let's do that. So let's take our x values. The first x value, see x1, that's 7. So we're going to put 7. That's our first x value. Our second x value is 9. So let's just add 9 and divide by 2. Okay, so now for our y values, let's take our first y value, which is minus 2. Add the second y value, which is 5, and then divide that by 2. So what we get here, what's 7 plus 9? That's going to be 16. So we have 16 divided by 2. And then minus 2 plus 5, that's 3. 3 divided by 2. So 16 divided by 2 is 8. So all we have is 8 in the x value, and then 3 over 2, let's just leave it like that. So that's going to be the midpoint. Let's make that 3 look a little bit better. Okay, so 8 and 3 over 2. So just it's a point here, not a number. So you add the x values divided by 2, then add the y values and divide by 2. Okay, is there anything else important from this section? I don't think so. That's good. All right, so let's move on to section 1.2. So what do we have going on in this section? Okay. Oh, maybe this might actually be easier. Let's we can make a, how did we do this? Oh, this is better. I don't know if I want to go by dates or, within here we can do a new page. So this was let's change the name of this one. Where do I, no. Just to make this a little bit more organized. Usually it allows me to change the name of this, but it's not allowing me to do that. Let's see what happens if I do a new page. How do I change the name of this one? Maybe let's not do it like this. I don't know why this isn't working. Delete that. Anyway, section 1.2. Okay. So the first thing let's talk about is what does it mean to be a function? And maybe you've heard of, the horizontal line test or the vertical line test. We've done that stuff like, maybe in high school or whatever, if that name just sounds familiar. So the first thing is what is a function? So, when we talk about a function, we always think like f of x is equal to something. F of x is equal to maybe, for example, 2x plus 3x squared plus 7. This is a function. So what it does that's important is it takes as an x value and it maps it to a y value. So for example, let's do a more simple one. Let's get rid of this so we can do it easier in our head. Let's just put like a plus 2 here. So something like this, f of x is equal to 2x plus 2. So it takes an x value, we plug in an x value, and we get this y value. We get a 2x plus 2. So a way we can think about this is that it takes an x value. So for this one in particular, how do we say this? So for this example, for the example, f of x is equal to 2x plus 2. What this function does is it takes an x value and then it brings it to this new number over here, 2x plus 2. So for example, it can take a 3 and it's going to turn that 3 into, 2 times 3 plus 2, which is equal to 8. So it takes a 3 and it turns it into an 8. The important thing is that it only takes 3 and turns it into 8. It doesn't take 3 and turn it into anything else. So it's okay to have the same y value. So we can have a number that, we can do a different example in a second. The big thing, let's actually just do one more example before I talk about what I was going to do it for. Now let's save this one for the example. F of x is equal to x squared. So here's a function. So for this example, what it does is it takes the x value and it's going to turn it into the number x squared. So what happens when we plug in 1? It takes 1, turns it into 1 squared, which is equal to 1. What happens when we plug in minus 1? It takes minus 1, turns it into minus 1 squared, but minus 1 squared is also 1. Notice here how it took the x value of 1 and turned it into 1, and it also took the x value of minus 1 and turned it into 1. That's okay. We're allowed to have the same y value. Something that we're not allowed to have is an x value giving two y values. So for example, here's something that's not allowed. Say we have some function. It turns some x value into some y value. In this example, we're not explicitly given, like in this previous example, we had f of x is x squared, and the one above it, we had 2x plus 2. Here, we just have some function. It turns x into some y value. Maybe it does something like this. It turns 0 into 2. It turns 1 into 2. But it also turns 1 into 3. So the problem is that if we look above, this function, it took 1, it turned it into 2, and also it took 1 and turned it into 3. This is not allowed. We can't have the same x value giving two different y values. So this is something that we can't have. So for this, so the above is not a function. Okay. Here, sorry, give me 1 second. Sorry, my car alarm was going off for some reason. I'm not sure if you guys could have heard that. Anyway, back to this problem. So this example here is not a function. That's the only criterion for being a function. We can't have that two x values give rise to different y values. Or sorry, the same x value gives rise to different y values. So this piece right here, so the same x value gives two different y values. And we're not allowed to have that. And so let me erase this a little bit so I can fit that in there. And this is not allowed. Okay, so for that reason, this is not going to be a function. So an example of, as long as we just have x values only giving rise to one y value, we're okay. If we have a situation where x values gives rise to two different y values, then it's bad. But notice how I said up above, we're allowed to have two different x values give the same y value. Here we had 1 turns into 1, and -1 also turns into 1. That's okay. The only thing that we can't have is the same x value giving two different y values. Okay, anyway, so let's do some problems from this section. So let's say if we look at, I guess we kind of already talked about that. What's that close? 21. What does 21 say? Okay. So let's do an example like we can do 22 together. So we have this this function f of x equal 5x squared plus 4x. What do we want to do? We want to find a couple of things. So we'll start basic and then maybe work up to some little things that might be a little bit more complex. So anyway, what does it mean when we want to find something like this, f of 0? Well, all that really is telling us is we want to plug in 0 for x. So this x really is just a placeholder. So whatever goes inside here, it goes here, and it also goes here. So now in this example, we want to find f of 0. So we're just going to replace all of our x's with zeros. So we'll have 5 times 0 squared plus 4 times 0. And it's always good to put our x values in with parentheses. That's just like a kind of a good habit to form. So 0 squared, that's a 0. So we have 5 times 0. Here's 4 times 0. Let's rewrite that again. So it's just going to be 0 times 0, or sorry, 0 plus 0, which is 0. So f of 0 is equal to 0 in this problem. What's another one we can do? F of -1. So what does this mean now? Well, all we have to do is replace all of our x values with -1s. So from that 5x squared plus 4x, let's make this 5 times -1 squared, and then plus 4 times -1. So this is going to be 5 -1 squared. So remember, if you square a minus sign, it goes away. So really, that's just going to be 1 times 1, which is just 1. And then 4 times -1 is -4. So here we have 5 minus 4, which is going to be 1. But we could also put in like a letter. How about if we plugged in f of y? Remember, all that means is all you're doing is replacing all the x values with whatever you're plugging in. So we're replacing all of our x values with y values. So this is just going to be then 5y squared plus 4y. We could do the same thing with a different letter, say like f of t. This is going to be 5t squared plus 4 times t. And now maybe plugging in something that's a little bit more complicated. What if we plugged in f of 1 plus x? Well, what this means is just wherever we see an x in the 5x squared, like we're looking right here, the 5x squared plus 4x, wherever we see an x, now we're plugging in this value in, 1 plus x. So this is going to be 5. So we're going to replace that x with 1 plus x squared plus 4 times 1 plus x. So if we simplify this, here's a formula that's really helpful to have memorized. A plus b squared is equal to a squared plus 2ab plus b squared. I think everyone should have that memorized. It just saves a lot of time. So if we're trying to let's simplify this. We have 5. If we want to simplify 1 plus x squared, If we have this whole formula memorized, all we do is we square the first thing, so 1. Then you take the a and b multiplied by 2, so 1 times x is just x multiplied by 2, so we have a 2x, and then square the last thing, so x squared. And then plus, and then we distribute the 4, we're going to get 4 plus 4x. So now we distribute the 5, so we have 5 plus 10x plus 5x squared. Now just rewriting 4 plus 4x. And then combining all the like terms, so 5x squared. We got a 14x. And then a 9. Okay, so then f of 1 plus x is equal to that. But maybe just to illustrate a point, what if we wanted to do something like this? F of a triangle. So again, whatever goes on the inside, all we do is replace the x value with that. So rewriting, this is going to then equal. So here's our equation. The 5x squared plus 4x. So all we do is just replace everything with the x's with whatever's inside there. Now what's inside there is a triangle. So this is going to be 5 triangle squared plus 4 times the triangle. So it doesn't matter what you're plugging inside this function. It's just whatever goes inside the parentheses, whatever goes inside here, these parentheses, that's just what goes here and what goes here. That x is just sort of like an arbitrary placeholder. It doesn't have, the fact that it's an x isn't too important. It's just whatever goes inside the parentheses. Okay. Whatever's going inside the parentheses just goes where all those x's are. Okay, what's another one we can do? Maybe try one of these on your, I need to charge my Apple Pen real quick. Try, what number did we just do? 22. How about, let's just write down a problem. Say if f of x is equal to x minus 3x squared. So try to find these values. Find f of minus 2, f of y, and f of z plus 1. So do these for a second. Let me just charge my pen, and we'll go over this in a minute or two. Okay, let's go over these ones. So for this first one, f of minus 2, that one's not too bad. All we gotta do is plug in minus 2. So we'll get minus 2 in for x, minus 3, minus 2 squared. So this is going to be minus 2, and then minus 2 squared, that's 4, times 3 is 12, so minus 12. That's going to be minus 14. The y, all I have to do is just replace the x's with y, so we're going to get y minus 3y squared. Okay, now the z plus 1, all we have to do is replace all of our x's with z plus 1s. So we see an x at the beginning, we're going to plug a z plus 1 in right there. Minus 3. Here's another x, we're going to plug a z plus 1 in right there. And then square it. So what we get is z plus 1 minus 3. Now z plus 1 squared, that's going to be z squared plus 2z plus 1. So this is going to be z plus 1 minus 3z squared minus 6z minus 3. All we're doing here is distributing that minus 3. Now let's combine the like terms. We're going to get minus 3z squared minus 5z and then minus 2. Okay, what do we have to do next? That's fine. Let's do let's do 30 and 32 together. So this is going to require, so when we're graphing, we'll talk about 30 first. What we want to do is graph this function. And then we want to use an XY table, but we need to also know what values we can plug in for the square root. Remember, with the square root of x, we can't plug in a negative number, so we can't find the square root of -1 or -20 or -0.3. The only numbers we're allowed to plug inside the square root are going to be numbers that are bigger than or equal to 0. And then we also want to have the general shape of this thing memorized. So we know that the square root of x, it looks something along these lines. That's the sort of, this is just the general shape of square root of x. So we have to keep both of those things in mind when doing this problem. So let's make an XY table. Another thing too, when we're plugging in x values here, we want to plug in x values that we can take the square root of easily. Say if we plug in 0 to the square root of x. Well, here, this situation, y is equal to square root of x minus 1. So this is, if we plug in 0, we're going to get the square root of 0 minus 1, which is just equal to minus 1 because the square root of 0 is 0. So we have 1 point right here, 0 minus 1. We would not want to plug in the x. Say if we plug in, we could plug in 1. Let's do that one. So if we do that, we're going to get square root of 1 minus 1, which is going to be equal to 0. Something that we're not going to want to do is plug in 2 because we're going to get the square root of 2 minus 1. And we can't simplify the square root of 2. We need a calculator for that. So we want to kind of avoid that. So let's not plug in the x value of 2. We only want to plug in x value so that when we plug it into this part of the equation, we can take the square root of it easily. So one thing that we can do is x equals to 4. If we plug in 4, we're going to get the square root of 4 minus 1. That's equal to, because square root of 4 is 2, so we're going to get 2 minus 1, and that's going to be equal to 1. Let's do one more point. Let's plug in 9. So we're going to get square root of 9 minus 1, which is going to be, so 3 minus 1, which is equal to 2. So we have all these points. Now let's plug these points onto a graph. The first point we did was 0 minus 1, so that's right here. 0 minus 1. The next one was at 1, 0, so put that one right there, 1, 0. The next one was at 4, 1, so something like over here. And the last one was at 9, 2, so maybe over here. And with this shape in mind above, we'll just sort of connect these dots in that kind of way. So it's going to look something like this. So it's kind of curved and just goes up sort of slowly. So the reason why we need to have this shape in mind is we're not connecting these dots with straight lines. We're connecting with this kind of curvy line. And we know because that's sort of what the square root of x does. So for this class, you know, it's like this is just a graph you have to have memorized. What does the square root of x look like? And it looks like this thing that I have in the box right here. Okay, so the next one to graph. Let's do 32. X squared plus 1. So for this one, we want to have, what does x squared look like? Well, x squared does, it makes like this like U shape. So this is something we're going to want to have in mind. So if we do this one, let's make an XY table here. And with this one, we don't need to worry about plugging in special x values because we can always find x squared easily. All we have to do is just multiply x times x. We can't always just find the square root of x easily. We need a calculator for that for the most part. So anyway, for this problem, let's plug in 0, or let's see what happens when we plug in 0 here. Well, actually, we can start with negative values. So remember, the square root, we just couldn't plug in. We just have to make sure there's no negatives inside the square root. X squared, there's no really restriction. We can take any number and square it. Let's start with, how about minus 2? If we do that, again, here, this is y is equal to x squared plus 1. So we're going to get minus 2 squared plus 1, which is 4 plus 1, which is equal to 5. Let's plug in minus 1. We get minus 1 squared plus 1, which is equal to 2. 0, we're going to get 0 squared plus 1, which is equal to 1. We could plug in 1. We're going to get 1 squared plus 1, which is equal to 2. And if we plug in 2, we're going to get 2 squared plus 1, which is equal to 5. So we have these points. So let's draw a graph and plug all these points onto the graph. So at minus 2, we're 5. So that's somewhere up over here. At minus 1, it's 2. At 0, it's 1. At 1, we said it was 2. And then at 2, we said it was 5. So here's these points. And now how we're going to want to connect these points is with sort of that curvy shape that we have in this box right here, the x squared. So let's connect all those dots like that. So it's going to look something like this. So that's how we would sort of graph x squared plus 1. Okay. So this next bit of questions, 35. Finding the domain of a function. So this is sort of what's important from this section. So the domain, domain of a function. So these are all the x values we can plug into a function. The x values that can be plugged in So what does that mean? Well, let's talk about something like f of x is equal to x plus 2. Actually, before we do that, let's talk about things that we can't have. So we can't have a number divided by 0. So this can't happen. And then we also can't have the square root of a negative number. For now, these are the only two things that we need to worry about for domain: square root of a negative number and a number divided by 0. So let's just do some, let's look at something like this. So f of x is equal to x plus 1. Actually, sorry, we're getting ahead of ourselves again. So let's talk about one more thing before we find the domain. So how to find a domain. We ask ourselves two questions. Are there fractions? And it doesn't matter which order we ask ourselves these questions. So are there fractions? Are there square roots? The reason why these are the only things we talk about when we're talking about a domain. And why is that? Well, because whenever there's fractions, we can't have the bottom of a fraction being 0. And whenever there's square roots, we just can't have a negative inside of the square root. So when we're talking about a domain, these are the only two things we need to ask ourselves. Are there fractions? Are there square roots? Every time the problem says, hey, what's the domain? These are the only two things you should be thinking about. Are there fractions and are there square roots? And that's what's going to allow us to do work to figure out what is our domain. So now let's do this with a couple of examples. So let's say find the domain of the following functions. So for this first one, how about let's just do a simple one. F of x, x cubed, x squared, x plus 1. Okay, so we always go back to those questions. Are there fractions? Are there square roots? So are there fractions? And we look at this problem. Well, we don't see any fractions, so that answer is no. Are there square roots? Again, let's look at this problem. There's x cubed, no square root there, x squared, no square root there, x no, so there's no square roots anywhere in this problem. That answer is no. Whenever you answer no to both of these questions, the domain is going to be all real numbers. So whenever this happens, this means our domain is going to be all numbers. So minus infinity all the way up to infinity. Whenever we don't have fractions and we don't have square roots, but this tells us is we can plug in any number. There's no number we can plug in here that's going to give us a problem. The only time we have a problem is if there's 0 on the bottom of a fraction or if there's a negative square root. If there are no fractions and there are no square roots, then it's impossible to get a 0 on the bottom of a fraction or a negative square root because those things weren't even there to begin with. So no fractions, no square roots, it means the domain's all real numbers. Okay, so let's do another example. How about something like this? X squared plus x all over x squared plus 5x plus 6. Okay, let's find the domain of this one. Oh, a equals f of x. So are there fractions of this problem now? And that answer is yes. Okay, so we do have a fraction. So let's go back. What happens? We set up here, we can't have a number divided by 0. So we can't have 0 in the bottom of a fraction. So that can't happen. So what does this mean here? What's the bottom of our fraction? Well, the bottom of our fraction is x squared plus 5x plus 6. We can't have that equal to 0. So because of this, we have to make sure x squared plus 5x plus 6 does not equal 0. Okay, so now we need to solve this equation, see what is x not allowed to be. This is a not equal to sign. Just pretend this is an equal sign, then all we do is we solve for x the same way we normally would. So we need a factor. So we need to factor this left-hand side to solve for x. So x doesn't equal 0. So remember how we factor is if we have an x squared, we write it like this. So now this is the way of factoring when there's a number 1 in front of the x squared, which it is in this situation. So all we're looking for now, if you guys remember, is we need numbers that multiply up to 6 and then add up to 5. And those two numbers are going to be 3 and 2. So we put plus 3 and a plus 2. because 3 times 2 is equal to 6, and 3 plus 2 is equal to 5. So we have to have this not equal to 0. So this means each of those pieces can't be equal to 0. So x plus 3 can't be 0. X plus 2 can't be 0. And this means x can't be minus 3. X can't be minus 2. Okay. Let's hold these for a second. Now let's talk about the square root problem. Or are there square roots? And that answer is no. We look at this problem above, there are no square roots. So the only issue is we had fractions. We had fractions, and if we set the bottom of the fraction equal to 0, the only things that we saw that were issues were x equals minus 3 and x equals minus 2. Whenever x is minus 3 or minus 2, the bottom of this fraction is going to be 0. And that's something we can't have. But that's the only time we had a problem. The only time we had a problem is, so let's think about this. The only time we can have problems are fractions and square roots. So there are no square roots of this problem, so we can't have a problem there, but we do have a fraction. And the only time we have a problem with a fraction is if the bottom is 0. The bottom of this fraction is only 0 when x is minus 3 and x is minus 2. So the only numbers we're not allowed to plug into this function are minus 3 and minus 2. So what we do now is we write our answer in 2 different ways. Let's put it onto a number line. And then the numbers that looking at these, we're not allowed to be minus 3 and we're not allowed to be minus 2. So here's minus 3. Let's put a circle there. Circle means we get rid of the number. Here's minus 2. Put another circle. It's kind of like a hole punch. We just get rid of those numbers. But those are the only numbers that gave us problems. So everything in the middle is okay. Everything to the left is okay. We never had issues with those, and we never had issues to the right. So the way we write this in interval notation, so this is like graph notation. Now interval notation, so we have minus infinity all the way up to minus 3. And remember, parentheses, so we always put a parenthesis on infinity. And if we have a circle, we put a parenthesis, and if we have a bracket, we put if we have a closed dot, like if this was a closed dot right here, this would need to be a bracket. But it's not a closed dot, it's an open circle, so we need to make sure that's a parenthesis. And then to connect these sections, we put this U symbol. Then we got minus 3 all the way up to minus 2. Another U symbol, minus 2 to infinity. So all we're doing here is putting, and this is going to be called interval notation. So both of these are the same answer. They mean the same thing. They're just different notations. Okay, let's do some other examples. How about let's do the nth root of x. And here n can equal either 0, 1. I'll start with not 0. It's going to be 2, 3, 4, so on. So either the square root, the third root, the fourth root, or so on. So this is just something to have memorized. So the domain here is going to equal 2 scenarios, either minus infinity to infinity if n is odd. So say if we take the third root, the fifth root, seventh root, an odd number, we can plug in anything. But it's only going to be 0 to infinity if n is even. So this is just one to have memorized. So what this is basically saying is if you have an even root, so like the fourth root, the sixth root, the eighth root, you can only plug in numbers 0 or bigger. If you have an odd root, so like a third root, a fifth root, a seventh root, we can plug in any number we want. So now let's use that to find the domain of, let's do 2 more together. So how about f of x is equal to the square root of x plus 1, all divided by x squared minus 3x plus, want to do plus 2? Yeah, that's fine. Let's do this one. So we always, when we're finding the domain, it doesn't matter how complicated the problem looks, we always ask ourselves the same 2 questions. Are there fractions and are there square roots? So let's start with the fractions. The answer is yes, so let's not worry about anything else. Let's only worry about the fractions. So what happens with the fraction? Well, we can't have the bottom of a fraction being 0. So what's the bottom of our fraction here? Well, this is going to be x squared minus 3x plus 2. Can't have this equal to 0. So we have to solve for x here. What does that mean? Well, if we factor this x, so what multiplies up to positive 2 and adds to minus 3? That's going to be minus 1 and minus 2. Minus 1 times minus 2 is 2, and minus 1 plus minus 2 is minus 3. So this can't be 0. So x plus 1 can't be 0. X minus 2 can't be 0. So x can't be minus 1. X can't be 2. Sorry, I did typo here. This is x minus 1 can't be 0. And x can't be positive 1. So x can't be positive 1, x can't be positive 2. Okay, let's keep those in mind. Now let's do, are there square roots? Again, that answer is yes. So let's take care of that. So what happens, another thing too that we need to mention, let's start this off to the side. If we just write like square root of x, that's just the same thing as this. If we don't write a number up there, that just means the number is understood to be 2. So 2 is an even number. So the square root, if you look up here at this little thing right here, part C, whenever we have an even root, we can only make sure the inside is 0 or bigger. So what does that mean though in this situation? Well, what's our square root here? Our square root is square root of x plus 1. Okay, so we do have a square root. The square root is square root of x plus 1. We need to make sure that the inside of our square root is bigger than 0. So say if we have, the square root of whatever's on the inside, we need to make sure, whatever is on the inside of our square root in this situation, this little blob, that needs to be bigger than or equal to 0. So that's all we need. We need to make sure the inside of our square root is bigger than or equal to 0. So in this problem, our square root is square root of x plus 1. In this problem, we have square root of x plus 1. So what this tells us is we need the inside of our square root, our x plus 1, this needs to be bigger than or equal to 0. Okay, so what this actually tells us is then that what we need is x to be bigger than or equal to minus 1. Okay, so now we have these two things. We have from the fractions, x can't be 1, x can't be 2. From the square roots, we have x just has to be bigger than minus 1. So both of these things need to happen. So first, let's go to a number line. The first thing we can do, let's just get rid of the numbers we're not allowed to be. We're not allowed to be 1. Get rid of that. Not allowed to be 2. Let's get rid of that. Now let's take care of the square root one. Bigger than or equal to minus 1. So here's minus 1. It says bigger than or equal to. So or equal to means we're going to put a closed dot on here because we're allowed to be minus 1. Now bigger than means we shade to the right. So we're going to keep shading to the right. But we're not allowed to be 1, so we're going to skip over that. Shade in the middle. We're not allowed to be 2, so we skip over that. And then over here. Okay, so this is the graph notation. So if we put this into an interval, we have a bracket on minus 1 all the way up to 1. Oh, sorry, why did I put an infinity there? A bracket on minus 1 all the way up to 1. Now connect it with the next section, 1 to 2. And then connect it with the far right section, 2 to infinity. So again, it doesn't matter how complicated your problem looks, this is always these two questions. Are there fractions and are there square roots? Okay, I think we have time to do, what was the last one? Yeah, we have time to do one more together. Let's do, I don't see one like that in the book. Let's just do another similar one like this. What is this? We just do D. Okay, here's E. Let's do the cube root. X plus 2 plus 1 divided by okay, the cube root of, let's make that 3 look nicer. The cube root of x plus 2 plus 1 all divided by the x squared plus 6x minus 7. Okay, so like we said before, it doesn't matter how complicated the problem looks. It's always the same two questions. First is, are there fractions? That answer is obviously yes. Here we see a fraction. So the bottom of the fraction can't be 0. What's the bottom of our fraction? Well, the bottom of our fraction is x squared plus 6x minus 7. So this is not allowed to be 0. So we need to solve for x here. What is x? So what's the issue with this then? Well, if we factor this, this is going to be x plus 7, x minus 1. Again, how do we know that? Well, because 7 times minus 1, that's minus 7. And 7 plus minus 1 is 6. So we factor that into this. This tells us that x plus 7, this can't equal 0. X minus 1, this can't equal 0. And here we're going to get x can't equal minus 7. Here we're going to get x can't equal 1. Okay, so now let's keep those in mind. Now, square roots. So really what we mean by square root here is actually is that an even root. That's really what we mean, because remember we looked above in this problem, whenever we have an odd root, there was no issue. We could plug in any number we want. All that really matters is an even root. Here we don't have any even roots. The only root we see is a third root, and that's an odd root. So this is just going to be the answer of no. Because all we have here, we have the cube root of x plus 1, but this is an odd root. So we don't care about odd roots. All we care about is even roots. So there's no even roots here, so nothing to worry about. So the only issues were when x is equal to minus 7 and x is equal to positive 1. So we go into our number line. Here's minus 7. Here's positive 1. Put circles on those because we just get rid of them. We're not allowed to be those numbers. But we could shade in the middle. We could shade on the left. And then we could shade on the right. And if we're going to put that into an interval, minus infinity to minus 7, minus 7 to 1, 1 to infinity. Okay. Is there any questions about any of the stuff that we did today, or just in general? Maybe like structure of the class or anything? Yeah, if not, this is basically all we have to do today. So these are the first two sections. I highly recommend to look at the homework and start the homework now, not save, because there's a decent number of problems. But with this material fresh in your mind, this shouldn't take you more than an hour to do these problems. But if you save it for Sunday night, for when it's due, this could take a lot longer than if you just do a little bit every single day. But if you have any questions on the homework, you can feel free to email me, and I can always just write on computer paper and take a picture and send it to you. But all these problems that we did, they're exactly the same thing, basically in order of the problems that we just did together today in class. Yeah, so if you don't have any questions, feel free to head out. And then otherwise, yeah, I'll just see you guys tomorrow morning. Oh, and I'll send you an email about what I'm gonna do with this video. But okay, yeah, so thank you. I'll see you guys tomorrow.